Welcome everybody, my name is Tim Sandy and I'm a VMware Technical Partner Manager and Systems Engineer. In this enablement session, I'm going to show you a demo of enabling and configuring Virtual SAN version 6.5. Just to keep in mind that Virtual SAN is actually built and the bits are actually in the vSphere hypervisor itself. So by proxy, vSphere version 6.5, when you enable vSAN, which is essentially what you're doing, you're just enabling it, you are actually at Virtual SAN 6.5 as well. Virtual SAN is not a separate product. It is not a virtual appliance that needs to be installed. It is baked into the hypervisor itself. So to take advantage of Virtual SAN, it's simply a matter of buying a license for it and getting the key and installing the key and then enabling and configuring it. So again, there's no separate install that's required of an appliance or another product. It is baked into the hypervisor. So I'm going to show you in the hands-on labs, and if you're not familiar with the hands-on labs, you can go to labs.hol.vmware.com, and we have labs for all of our different solutions in there, but we also have several for Virtual SAN, and we've recently updated to the Virtual SAN 6.5 version. So as you're going to see, I'm going to be using the hands-on labs environment to enable Virtual SAN and then do the initial configuration of it. And I'll go through some of the different areas within the vSphere web client associated to vSAN and what's available for you to use and to do your setting changes. So without further ado, let's get started with the demo. Okay, so here as you can see, I'm in the vSphere web client. Again, my hosts are vSphere 6.5. vCenter is 6.5 as well. So because Virtual SAN is actually in the hypervisor, in the vSphere host itself, it's not an appliance that I need to deploy or anything like that. vSAN is already built into the hypervisor itself. So really all it takes to enable vSAN, besides having the compatible hardware, assuming that, the only thing we need is a product key, a valid product key for when you purchase the licenses for vSAN. And with that, you can then enable Virtual SAN on a cluster. It's that simple because it is baked into the hypervisor, into those bits already. So again, I'm going to show you how to enable Virtual SAN 6.5. So as you see here, we have a cluster, this cluster here, region A01-comp01. In it, we have 3 hosts. Now, before we can enable a Virtual SAN cluster, the first thing that we have to do on our host, one of the few configurations that we do have to do, is we have to go, you click on the host, go to Configuration tab, and then go down to your VM kernel adapters. You're going to need to make sure that you create an adapter for vSAN specifically for that traffic of communicating that Virtual SAN information and data between the hosts. So you do have to create this vKernel adapter for vSAN. As you see here, if I scroll over, you're going to look, the services for vSAN are enabled, and you can also look here, enabled services is vSAN right here. So as we go down each one of these hosts, you're going to see that they already have that adapter set up for vSAN services here. So that's the first thing that we have to do. If you haven't done that, that's the very first thing you have to do before you can enable vSAN. And really, other than that and putting in the license key, that's all there really is before any type of configuration of having to be able to enable Virtual SAN. So being that we have that done, we're going to go back up to the cluster level here. We're going to go to the Configuration tab, and then you can see under Virtual SAN we have General. Now just to let you know, to add the Virtual SAN licensing is here under Licensing. So you simply just click the licensing, you're going to assign the license, put in the license, and that's all there is to it. I'm not going to bother with that. So going back up to General under Virtual SAN, we're going to go ahead and we're going to enable Virtual SAN. So I'm going to click the Configure button. Now, starting off, keep in mind our hosts have disks in them, and we'll see those in a minute. Now, you can have Virtual SAN go out and automatically grab any available disks automatically during the initial enable and configuration. I prefer not to do that, so I like to go to Manual. So I can make sure that I'm selecting the right disks, just in case you have multiple disks in there, that maybe you have one in there that's not meant to be for virtual SAN potentially. So, and plus this way, this kind of shows the creating of the disk groups and selecting the individual disks, showing you this manually. So we're going to select manual. Again, you can do automatic. Now, with all flash versions setups of virtual SAN to where you have flash disks both for caching and capacity tiers, you can turn on those space efficiency feature sets such as deduplication and compression. Now, being in this environment, we have flash disks. I'm going to go ahead and I'm going to enable deduplication and compression. I'm also going to allow the reduced redundancy. Now, we'll talk about this in a little more detail, fault domains and stretched cluster. In this particular demo, I'm not going to show the stretched clusters, and we're not going to configure fault domains. So I'm going to go ahead and click Next. Now, remember we went and looked at the VM kernel adapters to make sure that vSAN services is, there is a VM kernel adapter for specifically vSAN services and communication. Now, this is one thing that's new to 6.5 is we've now, as a part of enabling virtual SAN, we've now put this check in here to make sure that you already have those configured on the disk. Now, we manually went and checked them already, but here's a part of the actual enable and configuration step. We actually have a check process in here. And as you see, we did have them set up, and as you see, we got green check marks saying, yes, they are configured. So we're good to go. So we're gonna go ahead and click Next. Now here we can look at the disks. Now you're going to see in this environment that I have each host has a 5 gig SSD that's meant for caching, and then it also has a 40 gig SSD for the capacity tier. Now this is a demo environment, so that's why they're very small disks and there's only one capacity disk. Now you can look at these in either way during the configuration of this. You can either look at it by disk when you're going to select the disk, or by host. So here when looking at it by disks, if I expand these out, it's looking at all 3 hosts, and as you see, the 40 gig disks, here's each of the 40 gig disks on each of the particular vSAN hosts. Then we have the 5 gig caching disks, and here's each one of them for each host. Now we can also again look at this by host, and what it does is it shows you, and I'm just going to open up the one here, it'll show you the one host with both disks, the 5 gig caching, and the 40 gig capacity. Now, because this is a lab environment, they've already configured these as the caching capacity tier. But like if I go back to, say, the disk view, and these are all my capacity, what I would do is click on all of these, and then I would end up, if they weren't already configured, I'd click right here to say claim these disks for capacity, and then do the same thing for the caching tier as well. But that is already done because, as you can see, they've already been claimed for those. Okay, so normally you would have to do this manually in the manual configuration. So I'm going to go ahead and click Next because I'm going to grab all those disks. It's just a summary screen here. If everything looks good after you checked it, go ahead and click Finish. Now we're going to watch the recent tasks here, because it does take a few minutes in order to bring all of those hosts to claim the disks, and it does have to create a disk group, which I'll show you here shortly, for each one of those particular vSAN nodes. So I'm going to go ahead and we're going to wait for that to finish up. As you see, it's happening pretty quick, and as you see, it has completed. Now that it's completed, it's creating the virtual SAN data store, which I'll show you, and then it's formatting it in disk version 3, which is the formatting disk version for virtual SAN 6.5. So we're going to wait for that to finish as well. I'll go ahead and minimize that. Now while that's finishing, I just want to show you here, we're still on virtual SAN in general under the cluster level. As you can see here, we enabled virtual SAN, turned on, put on manual mode. We enabled dedupe and compression. Again, it is about ready to finish here, and you're going to see this change from one disk to, remember, we've got a total of 6 disks across all 3 hosts, 2 per host. So right now it's finishing up the disk format version. Right now it says 3 disks on version 3, but shortly it will show you 6. Sometimes you do need to hit the refresh to let it update. So it's still doing that. Now, you're going to see the setting here, internet connectivity. Now, if you have internet connectivity, which I don't in this lab environment, you can go ahead and turn that on. And you can click Enable. Now, if you have a proxy server, you can put in the associated proxy server information, the port, username, password, whatever, click OK, and turn that on. Now, what this does is you're going to see later on in the demo, there's a health check. And what it does is it checks the hardware versions of the controllers to make sure the driver versions are correct, the firmware versions are correct, and everything else. If you enable this internet connectivity, it can go out and automatically update the hardware compatibility list database in reference to all the different driver versions, firmware versions for all the hardware and everything else. And it'll do those checks and it'll tell you whether they're out of date in reference to what drivers need to be used for a virtual SAN. And by the way, as you see here, it finally finished up. Disk format version, all 6 disks are on version 3 now, which is a good sign with a green check mark. Now, as you know, one of the new feature sets of 6.5 is that virtual SAN can be used in iSCSI target service. For an example, at this point in time with 6.5, it's only meant for physical servers to be able to point to a virtual SAN data store using iSCSI. So an example would be if you have some physical Microsoft clustering service servers and you want to use the vSAN data store as their data location, you can point to it via iSCSI, create the target. You can go in here and enable it. To create the iSCSI target, enable the service, you're going to enable the service. You're going to use whichever iSCSI VM kernel that you plan on using. You're going to make sure that, typically, just like we did with the vSAN services, you're going to have a VM kernel that's going to be meant just for iSCSI traffic to keep that separate. It uses 3260 by default. You can use, if I enable this here, you can see you can use no authentication or you can use CHAP or mutual CHAP. And then if you have any data store policies, again, vSAN will deploy a default virtual SAN storage policies you see here, or if you're creating your others, you can associate it to that. I'm going to go ahead and click cancel because I'm not going to show the iSCSI target portion in this because this is just the initial install, enable, and configuration of virtual SAN. So this is just some of the general settings. Now let's go to disk management. Now we claimed all 6 of those disks, 3 for flash, the 5 gigs, and 3 for capacity, which were the 40 gig. And when it does that, it creates a disk group automatically for each host. So as you see, ESX3, 1, and 2, they've all created a disk group. In each disk group, you have one caching disk, which is the 5 gig, as you see here, caching, and then you have one capacity, which is the 40 gig. Now, for a virtual SAN and for a disk group, that is the minimum requirement for a disk group. You must have one caching disk and at least one capacity disk. There's no size requirement, but you have to have at least one of each. Now, you can have more than one caching disk in a disk group, and you can have more than one disk group, and obviously you can have multiple capacity disks in a disk group with one caching disk. Now, best practice is to have more than one disk group. That helps with, especially when we talk about resyncing later, that will help speed up the process of resyncing if you have multiple disk groups. That way, if you lose a disk in a disk group, you're only taking out that one disk group on the host and not the entire host, because if you only have one disk group and you say you lose your caching disk, then you lose everything in that host, and essentially that host is now unavailable. So just something to keep in mind. Now, here is the setting for the fault domains of stretch cluster. Now, stretch cluster, again, is to be able to stretch this vSAN data store across multiple physical locations. So like maybe your main headquarters and a secondary site. Fault domains, what they are for, you need to understand this. Now, let's take an example. We have a company, they got a data center. They've got, say, 100 vSAN nodes. And let's say they got them spread across 6 racks, physical racks. Well, when in a typical clustering fashion, when you deploy a VM, it's going to create, you're going to have your primary copy, it's going to create a backup copy, and then you need to have a witness in true cluster fashion. Well, the thing is that if you've got multiple physical racks and you deploy a VM, you don't want the primary copy, the backup copy, and then the witness to be on host all within the same physical rack. Because if that physical rack goes down, then you've lost everything. Okay, so we've given you this capability of doing fault domains. So in this scenario that I just gave you, we have 6 physical racks. What we're going to do is we're going to create a fault domain for each one of those physical racks. And we're going to put all the associated hosts in that physical rack in that fault domain. That will then, when we deploy a VM, it will ensure that it writes all of the objects in the virtual data store into different hosts on different racks and spread them across essentially 3 racks rather than putting them all potentially in the same physical rack. So if you lose power, again. So this way, if it spreads the objects, the primary VM, the backup VM, and the witness across 3 different physical racks on 3 different nodes in those racks, then if you lose one rack of power, you're not losing your data. So that's the idea of a fault domain. So if you don't have multiple, if you don't have the need for fault domains, as you can see, it puts it in a kind of a non-fault domain, which is essentially just like having them all into a single fault domain. But we're just going to leave it at this. We're not going to create a fault domain. Again, fault domain is for that situation. And stretched clusters, like I said, that's for when you're doing multiple sites. So for this particular example, we're not going to show you that. Now going down to health and performance, the health service is enabled automatically. It's version 6.5, and the interval is every 60 minutes. Now you can change this to whatever you desire, to either less or more, whatever you prefer. I mentioned before the hardware compatibility list database. So you can either download the file from VMware, the update for that, and point to the file, just like you normally would, point to the file and update the database that way manually, or you can get the latest version from online. Now, I'm not going to bother clicking this because, again, this is a test environment, and I do not have an internet connection in this environment, so it's not going to do me any good. But in most cases, you're probably going to be connected to the internet. You can click on this, and then you'll see the update date associated to the hardware compatibility list database change. And again, this is what, when we look at some of the health checks that I'll show you here shortly, it's going off this database. So it's a good idea to make sure that you have this up to date. Support assistant, if you need to put in a ticket, you're having problems with virtual SAN, you can upload a support bundle and attach it to a service request that you already have open. So this makes it very easy to do so. So you do have this option. Again, you will require an internet connection for that. Now the performance service currently is turned off. You can click edit, you can turn that on. If you have multiple storage policies, you can associate it to that, but we're just going to do it for the virtual SAN default storage policy. We're going to click OK. Now keep in mind that we're just turning this on. It will take a few moments for it to make the appropriate changes. There we go. From a performance aspect against that virtual SAN default policy, we are currently compliant and healthy, as you see the green check marks. Now again, if I was going to show you the iSCSI targets, I would show you that by coming into here. Again, clicking edit, you can enable it. You have to have that VM kernel for the iSCSI traffic. The standard default port is 3260. You can either no authentication, but if you want to be security CHAP or manual CHAP, and then again you can set it according to the policy, which is the default there, which we're not going to do. And then you can also set up iSCSI into shared groups. I'm not going to bother showing that to you. Again, the licensing here would be here to put in the vSAN license. Now I'm going to go back to the summary screen here. As you see on the cluster, we've got red. Because we just enabled that, some of the alarms are going to be initially kicked off. We're just going to reset those to green. Okay, so let's go over to our data store. So I'm going to show you that vSAN data store. So we're under data stores, we're under the data center object, and then as you see here, here is the default named vSAN data store. That's how it gets named. And as you see here, the associated default policy is assigned to it. The name is vSAN data store, which is default. The type is vSAN, of course. Capacity. Keep in mind we have those 3 40 gig disks for capacity. As you see here, total capacity is 113, and we have free space of 112 right now. Data store capabilities currently right now, because of configurations, storage I/O control and hardware acceleration is not supported. So going back to hosts and clusters, again we're on the cluster level here. I want to go to the monitor tab and show you the items in here. Now here are the basic checks. Now because it's set, if you remember, for every 60 minutes, I'm going to go ahead and I'm going to do a retest. This test here is pretty quick. So as you see here, once I retested it, now that vSAN is configured correctly, as you see, we've passed. But look at all the checks that we do. We do cluster. In the cluster, it does a bunch of different objects here. But here I want to show you the hardware compatibility, controller driver, control release support, iSCSI controller, vSAN HCL. As you see all that hardware type related stuff, as well as to the network, the physical disks. That was what I was talking about with the hardware compatibility list database and keeping that updated, especially for the hardware compatibility for your storage controller and the associated firmware version and driver version, because there are certain ones that you got to use for virtual SAN. You can't necessarily just update to the latest one. So going down to capacity, so as you see here, capacity overview gives you your total, your used total, your dedupe and compression overhead, and then you're free. Now, obviously, I don't have any VMs on this data store, so there's no objects in there, so you're not going to see any real savings, especially if you look over here, dedupe compression overview. We're only getting 712 meg savings, so 1.46x ratio. As we start adding VMs and putting objects into that vSAN data store, you will see these numbers go up here. Now, the use capacity breakdown, if you want to look at how that use capacity, what does it consist of? As you see here, performance management objects in the green is 8%. File system overhead is 0 right now. Dedupe and compression overhead is 74% right now. This is of used data, keep in mind. And then the checksum overhead is 17%. And that's by object types. You can also do by data types as well. So primary VM data, vSAN overhead, replicas, witnesses, RAID 5 components and stuff. So it's like I said, as you start to add more VMs and components into the vSAN data store, you're going to see these numbers drastically change. Now under recent components, now normally this is what you're going to see. You're not going to see any data because most of the time you're not going to be resyncing components. But let's say we lose a drive or we lose a host, or maybe we add a drive or add a host. Anytime we make changes to the size of that data store or the disks in it, it has to resync those components across all the available hosts and disks. So normally speaking, you shouldn't see resyncing happening unless you've done one of those things. You've either added capacity or either by host or disk, or maybe you've had a drive failure or a host failure to where now you have less, and that has to resync those components. The thing to watch out for is keep an eye if you are resyncing. There really hasn't been a reason that you know of, a failure, you haven't added anything, it's resyncing. You might want to maybe look into why. You also want to look at the bytes left to resync. This will give you an idea of how much time's left for resyncing. You won't go making a lot of changes while there's a resync action going on, especially deploying VMs or moving them around. Then we can go to virtual objects. Now, virtual objects here is going to be empty right now because we do not have any VMs and associated, VMDK files or anything like that. I can go back and show you that later. Physical disk, this is going to look like before under the configuration. You're going to see the disk groups and each disk under each host. iSCSI targets, we're not going to see anything because, again, we don't have that enabled. And then we have some proactive tests here. Now, one of the first things I do after you set up your vSAN and you've enabled it, the very first thing you want to do before you even think about trying to throw a VM on there or build a VM or anything is do this VM creation test. Run this. This is pretty quick. Again, it's going to take less than a minute. It's going to try to deploy basically an empty VM real quick, just to make sure that you can actually create a VM on the virtual SAN data store. So as you see there, we're creating a couple different ones, and then it removes them. So as you see there, we've passed that test. So that's good. So that means I can deploy something to the vSAN data store. Then we have the Multicast Performance test. Again, right now in version up to and including version 6.5, we do have to have multicast running between our hosts for inter-host communication. So I'm not going to bother having you wait for those other tests because those two take longer. So what I'm going to do right now is I want to show you how you can add capacity to a vSAN cluster. Now that could be adding additional hosts, or it can mean adding additional disks or an associated disk groups if you're adding SSD and regular capacity disks. So as you see here, we have this ESX04. Now just to check real quick, the VM Kernel Adapter, and just to show you, we do already have a VM Kernel Adapter with the virtual SAN enabled on that, so make sure you have that. Now what we're going to do is we're going to, while in maintenance mode, we're going to drag and drop into the virtual SAN cluster. Okay, so we're going to watch the recent tasks because it is going to have to configure that host and reconfigure the cluster. So it will take a few minutes to do that. Okay, so it's done adding, and you can see the yellow exclamation points are no longer on the other vSAN host. So now I can take this out of maintenance mode. And we're going to make sure that that's done. And it has. So now what I'm going to do is I'm going to go back up to the cluster level. Again, I'm going to go to configuration. Now I'm going to go back to disk management. Because now we've added a host with disks in it. You remember we originally set it up to manually configure virtual SAN and to grab those disks manually, not automatically. So it's not going to automatically grab them, so we need to manually go out and do that. So here we have the ESX host. Now from here what I can do is simply, there's two ways you can do it, either from the disk level or from the disk group level. So I'm just going to create a new disk group. I'm going to go about it this way. So here first we're going to select the disk for the caching tier. So caching tier again is that 5 gig. And then for the capacity tier is going to be that 40 gig flash. And we're going to click OK. Now it's going to take a minute to do this. It's going to create the disk group for ESX04 using those 2 disks. And again, it takes a minute to do that. You may have to refresh if you want to see it a little bit quicker. It does take a little bit of time. And you can watch here with the recent tasks again. Okay, so it's finished adding the disk to and creating that disk group for ESX04 as you see here. Here's a disk group, and in that disk group you have the 2 disks as we expected. Now we can go, let me show you the vSAN data store. So we go to storage, we go to the vSAN data store. This is again the default name. Again, we have the virtual SAN default storage policy assigned to it. The name is vSAN data store by default. Type is vSAN, of course. Look at the capacity now. Now, if you remember correctly, before we had like 114 gig. Now, since we've added that additional host with those disks, we now have 151 gig. Provision space is 2 gig. Free is 149. So I just wanted to show you that real quick, that by adding that host, we very simply have added capacity as well as compute resources, of course. So going back to host and clusters, again, we can see all of our disk groups for each one of our hosts. Now what I'm going to do is I'm going to go ahead and I'm going to move one of these VMs onto the data store. So I'm going to do both the compute and storage. Click Next. I'm going to select the virtual SAN cluster. Get a green check mark, it's compatible. Click Next. And right now I'm going to go with just the default virtual SAN storage policy. And as you see, the only compatible storage policy is the vSAN data store. And click Next. I'm just going to go with the default network settings. And you're going to review, make sure that all your settings are correct, and then we're going to click Finish. So that's going to take a minute to move that VM over. Okay, so as you see here, we've successfully moved the base-Linux VM into the vSAN cluster, and it's completed. So we'll go ahead and close that. Now, what I'd like to show to you is I want to go over the monitoring tab here, and I want to go to View Objects. I'm going to go ahead and refresh that. As you see here, now that we've moved a VM into, or I should say onto the vSAN data store, we now see the base Linux VM on there. And as you see, we have the VM home folder and the hard disk, which is the VMDK. Let me scroll this up here a little bit so you can see a little more on the bottom here. So as you see the VM home folder, we can actually look at the physical disk placement, where they are. So again, remember, the concept of a cluster is that we have one copy of a VM, we have a secondary copy of a VM as a backup that gets constantly synced with the primary, and then we have a witness. And as you see here, we can see our 2 VMs, these 2 components are on ESX04 and 02, and then the witness is on 03. So we can actually see where our components are sitting within the vSAN data store itself and which particular host that they're on. We can also look at the actual hard disk itself, the VMDK file associated. As you can see, it's in a RAID 1. The 2 components again are on 04 and 02, and the witness is on 03. We can actually see where these individual objects and VMs, where they're residing on what hosts. We can actually go in and see if we bring down this particular host, what components of which VMs are sitting on that host, and you can kind of preemptively maybe migrate VMs accordingly to do, say, maintenance on a particular host. Now, there's a way in order to do that. For example, you can, by best practice, you would put a vSAN node into maintenance mode, and when you do that, it's going to ask you, do you want to make sure that all of the objects on this particular host is continue to be accessible? There's a couple different settings that you can select, and if you say yes, keep them available, it will automatically move all those objects off that host and put them onto other active hosts to make sure that you are still able to access those particular VMs and associated files. Now I want to go to the home screen here, because another thing I want to show you is the default storage policy. So here we go into VM storage policies, and as you see, we have the default, or the virtual SAN default storage policy. Now let's just take a quick look at that real quick. You see some of the settings in there. Keep in mind there's multiple settings that we can do. Now, best practice is not to modify the default policy. It's best to clone it and then rename it and then make the setting changes that you want to that particular one. So starting off here, we have the number of failures to tolerate. Now, for vSAN, again, we have by default a minimum of 3 nodes. And the reason why in any standard cluster format, again, is you have the primary copy of the VM, you have the backup secondary copy of the VM, and you have a witness, so that requires your 3 hosts. And so if any one of those hosts goes down, you still have access to that VM and that data. So we have a failure to tolerate of 1, and that is the default. We also have the number of disk stripes per object. And by the way, you can click on any one of these little icons here, and they'll give you a description of what is meant for these settings. So for the number of disk stripes per object, the number of hard disks across which each replica of a storage object is striped. A value higher than 1 may result in better performance. For example, when flash read cache misses need to get serviced from the hard disk drive, but also results in higher use of system resources. So the default value is 1, maximum is 12. So again, you can get better performance on striping across more disks. And again, that's basic RAID type of concepts. Although the way vSAN works, it's not a true traditional RAID 5, 6, 1, or whatever. It's slightly different, but very similar in conceptually. Also, of course, provisioning. Default is to no. This means that, like, say we're in a degraded state where we lost one of our hosts. If you go to deploy a VM, are you going to want to still deploy that even though we're in a degraded state? Probably not. So that's why typically it is set to no, and why it is set to no by default. So just something to think about with that. Object space reservation. You can set a percentage of the logical size of the storage object that will be reserved, basically thick provisioned upon VM provisioning. And then the rest of it will be thin provisioned. Then we have flash read cache reservation percentage. So this is flash capacity reserved as read cache for the storage object, specified as percent of the logical size of the object to be used only for addressing read performance issues. So reserved flash capacity cannot be used by other objects. Unreserved flash is shared fairly among all objects. So as you can see there, if you have something that you're having issues with from a read perspective, you can assign a certain percentage of that cache disk to assign directly to a certain set of VMs. Because remember, all these policies are based by, you can do by VMs. You create a policy, then you assign VMs to those policies, or vice versa. You can also add some other additional rules, as you see here. Failure tolerance method, IOPS limits for object, and disabled object checksum. So that's a default policy in its settings. So like I said, best practice would be to clone this, and I'm going to call it new vSAN policy. And then we can click on rules. You can use common rules in the VM storage policy. Again, you can read the description here, but we're not going to get into that too much. Rule set is where we were setting the rules before in regards to stripes and number of failures to tolerate. Keep in mind that whenever you, for example, number of failures to tolerate, in order to increase this, this means you need to have more hosts. So right now with only 3 or 4 hosts, I'm limited as to the number of failures to tolerate. So if I tried to say 4 and do that, it probably is going to give me an error. See? incorrect missing values, because I don't have enough hosts to be able to handle a number of hosts of 4. So number of disk stripes, I could, let's say for this I want to do 2 stripes. It will also look at that too. Now by doing that, you're going to decrease the amount of storage. We can also do the forced provisioning, the reservation for object space, also flash read cache. We can add additional ruler if we want. The fault failure tolerance method, you can either do grade 1 for mirroring, or we can do erasure coding, 5.6 for capacity. So let's say that we're going to make that our policy. So there's my new vSAN policy. Okay, I'm going to go back to hosts and clusters. I'm going to click on that base Linux VM. Remember, the policy assigned to that base Linux VM was the default at the time when I moved it. It shows it is compliance. Now, if, let's say I just moved it into here, I can do a check compliance to make sure that it is reflecting correctly. And as you see, it is. So what I'm going to do is I'm going to take this Photon 01A and I'm going to migrate that to the vSAN data store as well. And change both the compute and storage. Click Next. I'm going to select the vSAN cluster, and it is compatible. Now what I'm going to do is I want to try this new vSAN storage policy that I configured. So as you see, data storage does not match current VM policy, requires additional physical disks. Because remember, I updated the number of stripes. I also updated the type of redundancy to 5.6. So I just wanted to show you that real quick. So depending on what your settings are in that storage policy, you may not be able to meet that. So if we put this back to the vSAN default storage policy, however, as you can see, it will meet that requirement. So I'm not going to go ahead and finish this. There's really no need for it. But I did want to show you that depending on what your settings are, you may not be able to meet the requirements. So I'm going to click Cancel. So now that I have that base Linux VM on there, I did want to go back to the data store. As you can see, the total capacity was 151. Provision space now is 16, and the free space is 146. So you can see now that we have that VM on there that it's not showing as much space available as before, which of course makes sense. Now going back to the virtual SAN cluster, going to capacity under the monitor and virtual SAN settings. Again, you're going to see that the numbers have changed now, especially for used capacity breakdown. Now also the dedupe and compression has gone up a little bit, 4.3 gig now, because now we have a VM on there, so there's some duplication of files. And then now we see for data types and for object types, the numbers are a little bit different now. As you see, we have this orange area now, which is deduplication and compression overhead, which is now 45%, which was a lot more than before. And now we have the green, which is virtual disk, which is 37, the VM home objects, which is 4. And as you see, the colors and the percentages have changed since I've added that VM on there, which is, of course, the way it should be. Now, just one added note going back to the proactive tests. Now, I did do that multicast performance test. Now, because this is a virtual environment, these are virtually nested ESX hosts, is why the performance fails. If this was a real live physical environment, more than likely this would pass, and then also your storage performance you could run and also pass as well. So just to let you know in regards to that. Going back to health, we can retest the health as well to make sure that we're still good on all the checks. And as you see, we're good. Now, just to show you real quick here with that ESX4, remember when we looked at the objects, we did show that there were some objects on here. Let's say we're going to put this into maintenance mode. Go enter maintenance mode. Now, as you see here, it recognizes that it is a part of a vSAN host. So it automatically checks the box move powered off and suspended virtual machines to other hosts in the cluster. And virtual SAN data migration. Now this is what I was talking about before in regards to doing maintenance. So if you leave this checked and you do ensure accessibility, essentially this is going to move all those objects to the other 3 hosts in the vSAN cluster, so 1, 2, or 3, to make sure that those objects get moved over to hosts that are running currently, and there's no issue. So I'm going to go ahead and do that. I'm going to click OK, and we're going to watch the recent tasks. So as you see, it successfully put it into maintenance mode. Now what I want to do is I want to go back to the cluster. You can either do it by the VM or the cluster, and then look at the virtual objects. Now if we look at that base VM, now if you look at that base Linux VM, as you see here, looking at the virtual objects, the VM home and the hard disk 1 are still compliant, but it does let you know that, hey, we have reduced availability with no rebuild delay. And that's because, we went from 4 to 3 hosts, but it did move those accordingly so that they still are available and they can still be seen. It noticed that we put ESX04 into maintenance mode, so it's missing those components that were on ESX04. But then if we go back and we go into maintenance mode and exit maintenance mode, go up to the cluster level, as you see now, the Linux VM is now healthy and everything is active. You can see all the components. So as you see, that is pretty much it for enabling and configuring virtual SAN. So that completes my demo of how to enable and how to configure virtual SAN 6.5. And again, just a reminder that virtual SAN is not a separate product. It's not a separate appliance that you have to install. It is built into the hypervisor itself. So whatever version you have installed as far as the hypervisor, such as vSphere 6.5, and once you have a valid product key that you can assign to vCenter server, you can then enable virtual SAN and configure it and start using it. So as you saw, using virtual SAN is very simple to enable and configure. In most traditional storage appliances, such as a NAS or SAN device, typically you have a storage administrator because it takes somebody with that kind of storage administration experience in order to install, configure, and manage that type of solution from start to finish. But as you can see with virtual SAN, a vSphere administrator that's familiar with working within the vSphere web client, even though without being a storage expert, can very easily enable, configure, and continue to manage a virtual SAN environment very easily. They do not need to be a storage expert in order to do that. So as you can see, I showed you how simple it was to simply enable virtual SAN. It took simply adding the product key, adding some VM kernel adapters, and enabling it for vSAN communication for that vSAN service, and then go off and enable it and do some minor configurations. You can configure some policies, either the number of stripes or number of failures you tolerate. Again, all of those can be limited based on the number of vSAN hosts you do have, so just keep that in mind as well. But again, as you see, it's very simple to use virtual SAN. It is a workhorse. The performance is outstanding. So virtual SAN is an awesome product. We have over 7,000 production customers that are using virtual SAN in their production environments. And virtual SAN has only been out a couple of years, and it was a new technology for us. So you can see that it's being widely adopted. And of course, as you know, also hyperconverged infrastructure is becoming very popular, like our VxRail appliance, which is a single physical appliance that has usually 4 physical nodes in it. And then we run vSAN on top of it, as well as some of our other solutions. Hopefully you see how easy it is to enable and configure and manage virtual SAN, even if you're not a storage expert. So with that, that completes this particular demonstration. I hope this information was valuable to you, and I look forward to seeing you on my future sessions. Thank you and have a wonderful day.